big, powerful, sizzling hot. The sun is really something. But how much do you know about it? Really? Do you know where it goes after dark? Do you know what it's made of? Do you think we could live without it?
1, 2, 3, 4.
Mission Control to Space Shuttle Columbia. Request launch checklist.
All systems are go.
Imagine that you're on a special mission to learn about the sun. You're bringing with you a super high-tech space probe, which will take never-before-seen pictures of the sun.
Launch minus 20 seconds.
As our journey gets underway, Mission Control wants to pass along your research list. You'll need to find out.
Why is the sun so hot? How big is the sun? Why do we get sunburned? Why is the sun so important? 5, 4, 3,
2, 1. And liftoff!
So settle back and enjoy the ride. We're going on a mission to learn about the sun. Did you know that our sun is a star? Just like the ones we see in the night sky? Of all the millions, even billions of stars in the universe, our sun is the star closest to Earth. That's why to us it looks so much bigger. Like all other stars, our sun is a huge ball of hot, glowing gases. Just as liquid gasoline is needed to make a car run, hydrogen and helium gases are the fuel needed to make sunshine. These gases are held together by the force of the sun's own gravity, the same kind of force that pulls everything on Earth down, toward the ground. The sun has been burning for 5 billion years, and will most likely burn for 5 billion more. The temperature on the surface of the sun is so hot that it could melt anything we have here on Earth instantly. And the temperature on the inside of the sun is even hotter. Out of all the stars in space, our sun is the most important star to us. It gives us light and keeps us warm. It causes our weather and helps plants grow. Most importantly, it helps to support all life on Earth.
The sun is huge. It's bigger than huge. It's over 1 million times larger than Earth. Think of it this way. If the sun were as wide as this giant pizza, then the Earth would only be as wide as this tiny olive.
Where in the sky is the sun when you go to school in the morning? How about when it's lunchtime? How about at the end of the day? The sun appears to move across the sky during the day and disappear at night. But actually, the sun isn't moving at all. It's the Earth that's moving, spinning like a giant top. The Earth constantly spins on an imaginary line that runs from the North Pole to the South Pole. This make-believe line is called an axis. It takes 24 hours, 1 full day, for Earth to spin all the way around. Scientists call this spinning movement rotation. As Earth rotates, one side of Earth is facing the sun, while the other side is facing away from the sun. When our side of the Earth faces the sun, it is day. When our side of the Earth faces away from the sun, it is night.
Never, ever look directly at the sun. Not with a telescope. Not with binoculars. Not even with a pair of really good sunglasses. You'll damage your eyes that way. So, if you want to see how the sun moves, you can make a sundial. First, try it indoors with a flashlight and a pen sitting on its end. Move the light back and forth and note how the shadow changes. Now, to make this sundial, you'll need a large sheet of paper and a straight stick. Using a pencil, punch a hole in the center of the paper. Then push the stick through the hole into the ground. When you see the shadow of the stick on the paper, use a marker to draw a line down the middle of the shadow. Label your line with the time of day. Wait at least an hour and go out to check your sundial again. Mark where it is now. You can repeat this throughout the day or hourly if you wish. That's all there is to it. You have built a sundial which shows how the sun has moved throughout the day. And if you check your sundial the next day, you'll be able to tell what time it is from the shadow on your timelines.
You know, spinning or rotating is not the only way the Earth moves. As it rotates, it also circles the sun at the same time. Our Earth and Moon are part of a system, a solar system. Solar means sun, and the sun is in the center of this system. The Earth, Moon, and 8 other planets and their moons constantly move around the sun. It takes Earth 365 days, which is 1 Earth year, to circle all the way around the sun. This is called 1 revolution, or orbit, around the sun. The Earth also tilts a little bit to one side on its axis and always stays at the same angle. So as it orbits the sun, the amount of direct sunlight striking the Earth changes, and that affects the temperatures in different places on the planet. This is why we have seasons. When the northern half of Earth is tilted toward the sun, places like the United States, England, and Russia are having summer. Meanwhile, the southern half is tilted away from the sun, and places like South Africa, Argentina, and Australia are having winter. But when the Earth travels to the other side of the sun, it's the other way around. Once in a while, as all this movement is going on, the moon lines up perfectly between the sun and the Earth and actually blocks the sun from our view. This is called a solar eclipse, and it can last for several minutes. But these eclipses don't happen very often. In fact, a total solar eclipse occurs only about once every 5 years. So when this does happen, it's a very special event.
When the first astronauts went to the moon, it took them 3.5 days to get there. But if they had decided to go to the sun instead, it would have taken them about 3.5 years. Now that would be a long trip.
Since the sun is made only of gases, there are no clear boundaries within it. But astronomers still divide the sun into 4 general layers. The center of the sun is called the core. The core is the hottest part of the sun. This is where the hydrogen and helium gases react with each other and create the incredible energy generated by the sun. This energy travels outward from the core to the sun's surface atmosphere, which is made up of 3 layers. The first is the photosphere. This is the part of the sun we usually see. The next layer out is called the chromosphere, where there are many solar storms. And the top layer is the corona, which is the hottest layer of the sun's atmosphere. Normally, we cannot see the corona from Earth, but when a total solar eclipse occurs, blocking out the body of the sun, we can see the corona glowing behind the moon.
Mission control to Space Shuttle Columbia. Prepare to deploy.
You have reached your destination, outer space. Floating high above the Earth, you are getting ready to release your space probe, which will go to the sun. A space probe is like a robot, which we control from Earth. By sending out probes, a lot of useful information can be gathered, and astronauts don't have to make such long and dangerous trips.
Mission Control to Space Shuttle Columbia. You are go for space probe launch.
That's a Roger, Mission Control.
Now let's check out some of the real solar missions that have explored the sun. This is the Skylab space station. Skylab, launched in 1973, was one of the first solar missions. 8 telescopes were on board just to watch the sun. Finally, we could study the sun from outer space. These dark spots on the sun's surface are called sunspots. Sunspots are like huge storms on the sun, but without any rain, of course. These enormous bursts of gas are called prominences. And these bright spots on the sun are called solar flares. Solar flares are big explosions of energy. In 1990, another solar mission was performed by Ulysses, a space probe specifically designed to study the sun. Ulysses was built by the European Space Agency, ESA, and carries equipment developed by European and American scientists. It traveled over the sun's north and south poles and sent back data to scientists on Earth. And in 1995, the SOHO space probe was launched. This was another joint project between the United States and European countries. At one point, scientists lost contact with SOHO and thought it might be lost in space forever. But 3 months later, they found it, and SOHO began sending information back to Earth again. Space probes aren't the only tools used to study the sun. Here on Earth, astronomers use special telescopes to look at the sun. Astronomers are constantly trying to figure out how the sun works and how it affects us here on Earth. Because our sun is a star, the more we learn about it, the more we can also understand all the other stars in the universe.
Long ago, many ancient cultures worshipped sun gods. Because these gods were believed to control the sun, the people offered them gifts such as gold and food to keep them happy.
Sure, the sun keeps us warm, but do you know why? Think about plants that grow in a greenhouse. When sunlight passes through the glass, some of it gets trapped, which heats up the greenhouse and keeps it warm. The Earth and its atmosphere also act like a greenhouse. Some of the sunlight that passes through the atmosphere strikes Earth and bounces back towards space. Some of that light escapes, but the rest is trapped by the atmosphere and heats up the Earth like a greenhouse.
How is the sun a source of energy? Let's investigate by making our own solar oven. You'll need a thermometer, a cardboard box, aluminum foil, black construction paper, tape, and a muffin or some other food you can heat up. Take the cardboard box and cover the inside with aluminum foil. Cover the outside of the box with black construction paper. The color black absorbs heat. The aluminum foil will trap the heat. Place the muffin and the thermometer inside the box. This is your solar oven. On a sunny day, place the solar oven in the sunlight. Measure the temperature with the thermometer. Wait 5 minutes. Check the temperature inside the solar oven. You'll see that it's risen. Check it again in another 5 minutes. Still getting warmer. Continue until the muffin is warm enough to eat. We've just seen how the energy from the sun can be turned into heat.
The sun may be just one of billions of stars in the universe, but it's the one that makes our life on Earth possible. Almost all living things depend on the sun for their food, as well as for heat and light. Life on Earth could not exist without it. Plants use sunlight as food to grow. Green plants contain a chemical called chlorophyll. Chlorophyll traps light, which combines with water and air to help make plants grow. This process is called photosynthesis. Plants don't have eyes and cannot see light, but they can bend and grow toward where it's coming from. Sunlight allows plants to grow strong and green. Because of that, animals can eat the plants and also be strong and healthy. People survive by eating the plants and animals. And it's all made possible by sunlight.
Sometimes too much sun is not all rosy, even if our skin is. Say hello to sunburn. Even though most of the sun's rays that pass through our atmosphere are healthy, a few are unhealthy. These are called ultraviolet rays, or UV rays. UV rays react with the cells on our skin and cause sunburn. Too much sunburn can damage our skin. So, to protect ourselves from ultraviolet rays, it's important to always wear sunscreen when you're outside in the sun.
Have you ever noticed the steam that rises out of a hot bath or shower? What about the water droplets that collect on the bathroom mirror? Well, believe it or not, this is how the sun warms the oceans and causes weather. When we take a hot bath or shower, some of the water disappears into steam or water vapor. This is called evaporation. But in the rest of the bathroom, the air temperature is cooler than the water temperature. So the warm water vapor in the air changes back into tiny droplets. This is called condensation. That's why we see moisture on the mirror, window, or walls. Now, if too much water collects, it gets too heavy and becomes precipitation. This is what we see dripping down the window. It's the same idea with weather. The sun's heat evaporates water into the atmosphere from oceans, lakes, rivers, and streams. The water vapor rises, cools off, condenses into tiny droplets, and forms clouds. The droplets stay in the clouds until they get too heavy. Then they fall back to Earth as precipitation, as either rain, sleet, hail, or snow. Then it starts all over again. This is called the water cycle, and this process has happened over and over for millions of years. And once again, it's all made possible by the warm rays of the sun.
The sun looks like it's close, just behind the clouds, but it's really far, far away. 150 million kilometers away to be exact, which is 93 million miles. How far is that? Well, if Earth was here and the moon was here, then the sun would be way over here. But that's okay, because if the Earth was much closer to the sun, like planet Venus, it would get so hot that all the water on Earth would boil away and evaporate. And if the Earth was much farther from the sun, like planet Mars, it would be so cold that all the water on Earth would freeze solid. So our distance from the sun is just right. Not too close and not too far. A perfect place for plants and animals to live.
Mission control to Shuttle Columbia. Begin
It's time to head back to Earth. So far, your mission went well, but it's not over yet. Are you ready to report back to Mission Control?
Why is the sun so hot?
The sun is a huge ball of hot gases, hydrogen and helium, which are held together by the sun's own gravity. The temperature on the surface of the sun is so hot that it could melt anything on Earth in an instant. And the temperature inside the sun is even hotter. With powerful telescopes and space probes, astronomers are able to view dramatic solar activity, such as prominences and solar flares. Here on Earth, we can capture the sun's heat energy and make it work for us. This is what we did when we built our solar oven.
How big is the sun?
The sun might not look huge to us, but that's because it's 150 million kilometers away. The sun is really massive in size, over 1 million times bigger than the Earth. If the sun were a giant pizza, then the Earth would be the size of a tiny olive.
Why do we get sunburned?
Even though most of the sun's rays that pass through our atmosphere are healthy, a few get through that are unhealthy. They're called ultraviolet or UV rays, and they cause sunburn. That can damage our skin.
Why is the sun so important?
The sun may be just one of billions of stars, but it is our star at the center of our solar system. Without the sun, we wouldn't have light so we can see, and heat so we can stay warm. Plants wouldn't grow, so animals like us wouldn't have any food to eat. All the water on Earth would freeze solid. And because there would be no water to evaporate, we wouldn't have a water cycle or weather. So you see, the sun makes Earth a great place to live. Shuttle Columbia to Mission Control. We have touchdown.
Mission Control to Columbia. Roger. Nice job, gang. Welcome back from your solar mission.